So I hope my screen would be visible. And to begin with, I will take one problem on rectifier. In last session also, I took one problem from rectifier. So here we need to compute the fundamental component of source current. And this problem was asked this year only, 2022, for 2 marks. And here, AC to DC rectifier, can you recognize which type of rectifier is this?
Symmetric rectifier.
Yeah, symmetric semi-converter, you can say. So here we will draw the waveform of the current and voltages, and then we can easily find out the whatever is asked. So let me draw. So input sinusoidal signal is provided, Vs, and based on this, so from alpha to pi, uh, let us say T1, D1, T2, D2. So from alpha to pi, T1 and D1 will conduct. Okay. And from pi to pi plus alpha, since this diode will be off after pi, so diode D2 will try to freewheel the current. Since no any freewheeling diode explicitly provided, so current will try to freewheel through D2 and T1 and it will short the source. So current will flow in this manner from alpha to pi plus alpha. And the devices which will be turned on during this period would be T1 and D2. After that, pi plus alpha to 2 pi, at pi plus alpha, this T2 will get turned on. So T2 will conduct and D2 anyway will conduct because that is uncontrolled switch. So in this manner, I will draw one more, or I will write for one more instance that 2 pi, 2, 2 pi plus alpha, or you can say 0 to alpha, both is same. And here D1 will start and T2 was already conducting. So from 0 to alpha, this D1, T2 will freewheel the load current. So now we all know that which devices will conduct for which instance. So based on that, we will draw. This is omega t axis. So here alpha is 45 degree. It is provided in the problem. So we will draw for that. V naught. This is the waveform of V naught. And had it been a full bridge rectifier controlled, or had it been all the devices be thyristor, then this could have gone to the negative axis to satisfy the criteria. What is the criteria here? The criteria is here that load current is constant, or the load current is ripple free, that is 15 ampere and ripple free. It means that current is continuous, and to maintain that current, here devices would conduct continuously. But since diodes are given here, so current will conduct through load side, but it will not be continuous on source side. So, and when diode will conduct, so you can see the voltage across load would be zero, since a short circuiting is happening here. So plus minus, you can see this voltage will be zero during T2 and D1 will conduct, and when T1 and D2 will conduct. So this voltage will end here, and after that, when T2 get turned on, at pi plus alpha, it will follow the same supply but in reverse manner. And let me write the device's name which will conduct. So here D1 D1, here D2 D2, here T1, sorry, T1 D2, and here T2, sorry, here T2 D2, here T1 T2. So actually we need to find the current waveform from source side, but until we know which kind of pattern is there, we can't exactly know how the source current will flow. So now we know this voltage waveform and when source will conduct. So for that purpose, now I can easily draw the source waveform, right? How? When T1 and D1 will conduct, so source current is equal to IDC. So when T1 and D1 is conducting, IS is equal to IDC. And when this freewheeling condition is being satisfied, then no current is being drawn from the source. So only load current is freewheeling and source current would be zero. So for this period, IS would be zero. And for this period, IS would be zero. But here, IS will have IDC, but in negative side. When T2 and D2 will conduct, then IDC is equal to minus IS. So that you can visualize from this circuit. So that's why this all waveform and drawing was important. So now I can easily draw the current waveform of IS. So from alpha to pi, IS would be equal to I naught, and from pi plus alpha to 2 pi, Is would be equal to minus I naught. Okay. So this is the waveform of semi-converter, as you can see, and it's fundamental we need to find out, so that it would have some sinusoidal component, alpha to pi. But to get even symmetric, we can shift it towards we can make it as a half wave symmetry. To make it, we can shift it by alpha by 2 so that it will be symmetric across this pi axis. So to do that, alpha by 2, pi minus alpha by 2, pi plus alpha by 2, 2 pi minus alpha by 2. So it is symmetric about this pi axis. We made it symmetric so that we can easily compute the Fourier series of this waveform. And now its Fourier series will be this symmetric 2 pi. And that factor, since in full bridge thyristor based rectifier, when source is not freewheeling, when source is continuously conducting, then this square would have been a full square wave kind of thing. But now some portion get chopped off. So that portion would reflect in its formulae or its expression. So earlier its expression was like Is is equal to summation 1 3 5 to infinite for I naught by n pi sine n omega t. Now, this expression will have some factor of alpha because it gets shifted by alpha and it gets chopped by alpha. So for that reason, that cos n alpha by 2 comes in the expression. And again, and now this is not original waveform. The original waveform is this one, which was shifted by alpha by 2. For that reason only, it will reflect in this expression plus alpha by 2. Because this waveform got shifted by alpha by 2 towards left. So that's why I am doing plus alpha by 2. So any confusion till this point? So if not, then I
No,
will.
sir.
Thanks. So then I will move on. Huh. Now I can calculate IS1 from this expression easily. So for that reason, IS1 will be equal to 4 I naught by pi cos alpha by 2, and this will be magnitude, and sine n omega t plus alpha by 2 would be its angle. So we only need magnitude since we can see the problem here. This I naught is given 15 ampere and alpha is given 45 degree. So we just need to compute the amplitude of fundamental component of the source current. So that I will do here. So it will be equal to 4 into 15 by pi cos 45 by 2. So after calculating this, let me compute this. 3 by pi 2 cos 45 by 2. So it will come around 17.64 ampere. So that will be the magnitude of source current, fundamental component of source current. So I hope this is clear to you. If any doubt in this problem is there, we can clarify. Any doubt in circuit waveform, anything? I hope this type of problem is discussed earlier, but anyway. If not, then I will move on to some another problem. And this problem is based on sine PWM, and this problem is also asked this year only. So this is the problem. You can read here. This also asked for 2 marks. And here, grid is connected to a DC link voltage of 1000 volt, and it is switched using sinusoidal pulse width modulation. And grid phase current is 10 ampere, and three-phase complex power supplied by the converter is given. Right? So the S is given minus 4000 minus J 3000. So this is active power and this is reactive power. So we can write S in kVA or VA only. So S would be equal to 4000 square plus 3000 square. So that would be 5000 or 5 kVA. Okay. So S is given here, phase current is given here. So why not compute the voltage? Do you understand on grid side, the all components would be AC, right? And towards DC link, all components would be DC. So in this manner, the connection is done. So let's say this is VSC, voltage source converter. So here this grid is supplied with some voltage. That voltage is not given, and its frequency would be some 50 hertz or 60 hertz, and its kVA is 5 kVA. And now we are given with phase current. So phase current is 10 ampere, and we can compute the voltage. And if we compute the voltage, so uh, this voltage, whatever will be on this side, on AC side, this is AC and this is DC. So the relation between modulation index and AC link voltage or DC link voltage is such that is related by this formula V naught 1, the fundamental component of output voltage towards AC side is equal to this peak of fundamental is equal to this phase value of peak of fundamental value is related to modulation index into VDC by 2. This formula is very repetitive. It has been asked in GATE multiple times, so you should keep this in your mind. And so for that purpose, we need to compute this M. And VDC is given, but V naught 1 phase is not given, right? And V naught 1 phase will be equal to V naught 1 is equal to V naught. Why? Can anybody tell me why this fundamental component is equal to output RMS voltage? Why I am writing like this? V naught 1 is equal to V naught. I will give a hint. This relation has something to do with grid side frequency. So, do you know grid side has some harmonics or not? Anyway, so uh, let me go ahead. So, why I was saying that V naught 1 is equal to V naught because grid will have a strict sinusoidal voltage. In our home or in any industry, whatever the voltage that provides, that is pure sinusoidal. All harmonics come due to power electronics component, right? So on grid side, that voltage is produced by purely sinusoidal. So that voltage will be always sinusoidal. So that's why V naught 1 is equal to V naught, and all the harmonics 3, 5, all the harmonics would be 0. So that's the reason. And let me compute the voltage value here. So S is equal to root 3 VL RMS IL RMS. So 4000 is equal to root 3 VL into IL will be equal to phase current. Generally, if nothing is mentioned, you have to assume that it is connected in a star. So in a star connection, line is equal to phase. And for that reason, I am writing ILRMS is equal to 10 ampere. So we can compute VLRMS easily here, and that will come out to be 4000 divided by root 3 into 10. So that is 230.94. Oh, sorry, it was 5. So now this value will change. 5,000 by root 3 into 10. So that will come out to be 288.67. Okay, so we computed line value of RMS voltage of the grid side, and once it is computed, now we need to find out the phase value and peak. So V phase RMS would be equal to VL RMS by root 3. So that will be 288. So that would be 166.67 volt, and its peak V phase RMS peak would be multiplied by root 2. So V naught 1 phase peak would be multiplied by root 2. So 166.67 into root 2. So that would come out to be 235.7 volt. So we calculated this value. Now we just need to put here and we will get the answer. So M will be 235.7 divided by this VDC by 2. So that will be 500. Since VDC was 1000, so VDC by 2 is 500. So that will come out to be 0.471. So this was the answer. Any doubt in this problem? So I guess you understood this part. And okay, so I will discuss another topic which is based on air gap flux density in machine, in DC machine generally, that kind of question you face. And I got that problem from one aspirant. So let me share that problem. Or do you guys have any particular thing to study or any particular demand of topic that also I can do? So this problem I got from one aspirant. He asked like he is not getting the correct value of flux density in air gap, and this is very misunderstood thing, how to calculate flux density in air gap. So let me show you some way by which we can compute. So we all know that EMF is equal to K phi omega, and this flux is flux per pole, right? And flux is equal to B dot ds, or average air gap flux density into area, and that area, this flux per pole, we can write in this manner. Now area would be, let's say this is rotor and this is a stator. So this area would be the component. We take one axial component and we take this radial component. So for one pole pitch, this circumference and this length that will correspond to our area, and this is considered as our D, and that D is known as a stator bore diameter or radius. You can say air gap radius. So RRO, RRO. Okay. So that area you can easily write as pole arc into a stack length. So this area is in simple language you can say the area, this area I am talking about, you can say pole arc into a stack length. A stack length is generally in J direction. So now here a diameter of pole shoe was given in this problem. Here diameter of pole shoe was given, that was 0.38 meter, and the poles are 0.2 meter long and subtend an angle of 60 degree. So what this statement mean? So this statement means that let's say this pole pitch is this much, but the pole arc that subtend only 60 degree. So one pole pitch is always 180 degree. Pole pitch is always 180 degree electrical, right? Electrical. Now, if it is saying that it subtend an angle of 60 degree, means 60 degree is not contributing in linking of flux from a stator to rotor. So this pole pitch was 180 and pole arc will become 180 minus 60. So pole arc will be 180 minus 60. So that will be 120 degree. Okay, so this statement does mean that you can use 120 degree as a pole arc. So in active area, this was if you would have used pole pitch at the place of pole arc, it would give you total area in the air gap. But when it is said that you can use active area of this much, then you have to use 120 degree of the length. So I hope no confusion in this. After that, to compute this area, what you can do? You can do like this. You can write pole pitch into 120 degree by 180 degree. Why? 180 degree will be always there. This is pole pitch, and you are using 120 degree out of 180 degree to make pole. So that will be your pole arc, and the stack length is always already there. So this formula, area, active area, is modified to this formula, right? And how to compute pole pitch? 2 pi r, right? Or pi into d. So that you can do here. Pole pitch is equal to 2 pi r r o. This radius from center to this. Okay. Into 120 by 180 into a stack length. So this diameter is given. Diameter of pole shoe circle is 0.38 meters. So that I will take as pi into 0.38 meter. And this was divided with pole also, flux per pole. But let me take as of now only area, active area. 180 into a stack length is also given, that 0.2 long, 0.2 meter long. So this is it. So Active area will come out to be 2.2. So it will come out to be 0.159 mm square. And now I would like to compute the flux per pole. So flux per pole is given here. I think no, flux per pole is not given in this problem. So how we can compute flux per pole? Any idea? Another concept was hidden in this problem. It is said that it is a shunt generator, so we need to perform a KVL in this circuit or in this motor. So terminal voltage is given 250 volt, a speed is given 400 RPM. We know one formula which is related to a speed and back EMF or voltage. So we can compute from that concept. Okay, so for that thing, I will take help of that formula, and that would come out to be E is equal to Z phi n by 60 into P by A. And since it is lap wound, so parallel path would be equal to number of poles. So let me write it. We all know back EMF in DC machine is equal to Z phi n by 60 into P by A. Okay. So since parallel path, this lap connection A is equal to P, so this will get cancelled out. So now we are left with only Z phi n by 60, and the number of conductors are given. 652 conductors are given. Okay, so Z we know, phi we can compute from there. N is also given 400 RPM, and E is not given, but E we can compute from a KVL equation. Since it is a generator, so E is equal to V plus IA RA. Okay. Now V is given 250 volt plus IA. IA is not given now. Again, to compute IA, we have to take help of this power. Okay. So plus IA into 0.16. Are you getting this? Or if you are stuck at any point, please just stop me. So to compute IA, I will take help of this power. So power was 2 kilowatt, 20 kilowatt, sorry. So 20 kilowatt will be equal to V into I. V we know 250. So I we can easily compute from here. 80 ampere would be your armature current that will flow through this circuit. And with the help of this, we can compute E, and E will come out to be 250 plus 80 into RA, that is 0.16, and this E value will come out to be 262.8 volts. And now we know the value of E, 262.8 volt. So 262.8, and this Z was 652. 652, N is 400. By putting all the value, you will get the value of flux per pole that I have computed here, and that you will get about 0.0603 Weber. So we got flux per pole. So we applied 2, 3 concept of the DC machine in this problem. And at the end, we will go there and we will find this by putting B into A active by number of pole. So we was asked this value Bg we need to calculate. So for Bg equal to flux per pole we computed 0.0603 into active area is 0.159 mm square. So to compute in proper unit, so mm square to convert to meter square, that would be 10 raised to power minus 6 divided by number of pole that was given 4 pole. So it will be divided by 4 and this Bg value will come out to be 1.52 Tesla. So this is all procedure how to compute air gap flux density. So if any doubt in this problem, I will be happy to take. I know this was a very long problem. This type of problem you will never face in GATE. But anyway, to solve long problem, it will give you confidence to solve shorter problem.